Welcome to Gadit Nidhi, the treasure of mathematics. Today we will look at an interesting recurrence problem. Let's take some time to read through the problem. In the plane, let the positive end of the x-axis be directed towards east and the positive end of the y-axis be directed towards north. Suppose you are at 0, 0 and you want to go to 7, 12. At every move, you are allowed to move unit length towards east or unit length towards north from your current position. But you're not allowed to visit any point h, k where both h and k are odd. Find the number of such paths n. This problem was posed on September 28, 2025 in IOQM. Let's take some time to understand the problem. On the right side, you see the vertices each at a distance of 1 unit going right or 1 unit up. Their coordinates are mentioned near each vertex. Our task is to find the number of ways in which you can move from the coordinate 0, 0 to the coordinate 7, 12. One constraint that we have to follow is that we cannot pass through a vertex whose both coordinates are odd. So 1, 1, 1, 3, 5, 7 are all prohibited vertices. All the coordinates marked in red are prohibited while we go from 0, 0 to 7, 12. Obviously, there are a number of ways in which we can travel from 0, 0 to 7, 12 with this constraint. One such path is shown here. We have to find the total number of such paths for traveling from 0, 0 to 7, 12 with a constraint that we cannot pass through any of the red marked vertices. Now pause the video and try solving this. Go ahead and watch the solution when you are ready. Let's define a function f of x, y as the number of ways in which one can reach the vertex x, y from 0, 0. We want to find f of 7, 12. As I said before, whenever both x and y are odd, there is no way to visit that vertex. So f of x, y would be 0 whenever both x and y are odd. So f of 1, 1 and f of 3, 7 and so on are all 0. So this function is 0 for all the vertices which are marked in red. Note that when you want to reach a vertex, say 2, 6, there are two ways you can reach this vertex. First, by moving right 1 unit from 1, 6 to 2, 6, or by moving 1 unit up from 2, 5. So the number of ways of reaching 2, 6 is the sum of number of ways of reaching 1, 6 and that of the number of ways of reaching 2, 5, or f of 2, 6 is equal to f of 1, 6 plus f of 2, 5. And if you want to reach vertex 3, 8, you can do something similar by moving 1 unit from 2, 8 or moving 1 unit up from 3, 7. But there is no way to reach 3, 7 because both x and y coordinates are odd. So the number of ways in which one can reach 3, 8 is same as the number of ways of reaching 2, 8. Similarly, if you want to reach the vertex 6, 7, you can do so by moving right 1 unit from 5, 7 or moving 1 unit up from 6, 6. But there are no ways to reach 5, 7 because both x and y coordinates are odd. So the number f of 6, 7 is the same as f of 6, 6. Now let's summarize what we have noticed so far. The number of ways to reach a coordinate can be found out by summing two numbers. The number of ways to reach the vertex just left to it, and the number of ways to reach the vertex just below it. However, sometimes one of these two component numbers may be 0 as that particular vertex may have both its coordinates odd. Now let's generalize this for all vertices. For a vertex n, m, if n and m are both odd, f of n, m is 0. Otherwise, we add f of n, m minus 1, which is the number of ways to reach the vertex below it, or f of n minus m, m, which is the number of ways to reach the vertex just on its left. Of course, we have cases when one of these two components is 0, as the coordinates of that components are both odd. And there are base cases. There is only one way to go from 0, 0 to 1, 0, which is to move 1 unit right from 0, 0. And there is only one way to go from 0, 0 to 0, 1, which is moving 1 unit up. Now let's create a grid which we will try to fill in. Each cell in this grid represents the number f of x, y, that is the ways in which you can travel to this vertex x, y. And using the information that is summarized on the left side, we will try to fill in this grid. Let's start with the case when both the coordinates of the vertex are odd. We fill in 0 in all those cells. So cells like 1, 1, 3, 1 and so on are all 0. Now we will fill in the number of ways to reach 1, 0 and 0, 1, which is 1 for both the cases. Note that if you want to reach any vertex f of 0, m, there is only one way to reach, which is to keep going up. So let's put 1 for all such vertices. Similarly, if you want to reach any vertex f of n, 0, there is only one way to reach, which is to keep going right. Now let's fill in 1 for all these cells. To fill up the remaining non-empty cells, we can add the value from the left of that cell to the value in the cell below it. Let's do that now to arrive at the values for the row number 1. We can continue to fill in the values in the second row, and so on. And this fills up the row number 2. Similarly, we fill up the row number 3, row number 4, 5, 6, 7, row number 8, row number 9, row number 10, row number 11, and the final row, row number 12. Thus, we have filled up the entire grid. Remember, each cell in the grid represents the number of ways to reach that position from vertex 0, 0. And so we have finally arrived at the answer to this question, which is 84. Thank you for watching. Hope you enjoyed solving this problem. And if you did, share this video with your friends and subscribe to this channel. Bye.